I'm Julian Lovelock. I'm the product manager for Amazon Verified Permissions, a new service from AWS. I'm based in Northern California, moved here about 16 years ago from London, and looking forward to talk to you about the product.
Hi, I'm Abhishek Pandey. I'm a product manager with AWS on the Verified Permissions team. I've been living in Seattle for about a couple of years and moved here from Austin.
So today we're going to talk about the service, what it is and why we built it. I'm going to share some feedback from a gated preview or private beta that we've run over the last 6 months. And then we're going to get into the meat of it with a demonstration of a sample application that you yourselves can download and access in order to better understand how the service can be used. So let's get started. Amazon Verified Permissions is, as the name suggests, all about permissions. So what are permissions? Well, permissions are the set of rules that describe what a user of an application is permitted to do. If you're an application developer building an application, you need to think about how you manage and control what users of the application are allowed to do, what functions they're allowed access to, what data they can get to. Verified permissions provides a way for you to formalize that definition of those rules in the form of policies. And we'll get into that in a bit more detail. But why are permissions so hard? Historically, permissions have been coded into the application, which doesn't sound too difficult. If we imagine ourselves building an application to manage data about books, then we might have a get book request as part of the APIs of the application. And we'd start to think about who is allowed to call the get book request. Well, we might start with a rule that says if you're the owner of the book, you can call that function. Fine, simple enough. But then we want, okay, the administrator should be able to get to any book in the system. So we'd need to add another rule into our logic to call out that an administrator can access the book. We might then decide that multi-factor authentication is a critical gateway. And so we would add another rule into our permissions logic that requires users to have authenticated with multi-factor authentication to call this API. And then we've got books that are public that we don't worry too much about protecting the information on. So we have another rule that says, well, if the book's public, of course, anyone can get to it. And you can see by this point that the logic around the permissions management is beginning to squash the logic around the actual function off the bottom of the page. There has to be a better way to do this. And indeed there is. By externalizing these rules into policies, we can replace all of this logic within the get book function with a single call out to an external authorization service. So now we can make a call out, is the client authorized to call this function? And the authorization service can evaluate that request based on a set of policies that describe who is allowed to make that call. This policy, for example, says that you can make the call if you are the owner of the book. This one says that an admin can get to those book details. This one requires multi-factor authentication. So you can see we've externalized the policies into a permissions management system, excuse me, where you can centralize the rules about who is allowed to do what within your application. So that is the basis for Amazon Verified Permissions. It's a service that enables you to manage a set of policies that describe who is allowed to do what within the applications that you're building, and provides an authorization service that lets your application call the service to evaluate those policies each time a user within your application attempts to take an action. We launched this service under gated preview back in November 2022. The gated preview was hugely instructive to us. We had over 500 customers requesting access. We onboarded over 90 customers to the service, all of whom we talked to individually as product managers. And I want to summarize here some of the things that we learned from those conversations. What did you as customers tell us? Well, the first point is one size fits all. Well, what do I mean by that? That's a pretty bold and in some ways slightly loose statement. Well, as you might imagine, across our gated preview, we saw a wide range of different types of applications, different use cases, different architectures. And in a second, I'm going to get into some of those different types of applications and explain some of the idiosyncrasies of them. But what we learned very gratifyingly was that regardless of the type of application, the CEDAR policy language, which is the underlying language in which permissions within verified permissions are expressed, provided the flexibility for multiple different types of authorization models. And this gave us the confidence at the start of May the 10th, to announce that we were open sourcing CEDAR, both the language specification and also an SDK that enables you as developers to use and build applications yourself that evaluate policies locally within your application, if that's the design paradigm you want. And you can see here on the right an example of a CEDAR policy. Actually, you can see two examples of a CEDAR policy. I said I'd talk a little bit about the different types of applications and how they varied in terms of their requirements for permissions management. We saw three types of applications that our customers were building using verified permissions to manage the permissions and authorization within those. The first was what we describe as internal service access. These are applications built by employees that enable other employees to access the organization's data. Characteristics of permissions management within these applications is that the users accessing the underlying data tend to be organized into nice hierarchies, representative of the organizational hierarchy within the enterprise. And associated with those hierarchies are different roles that describe what different users are permitted to do. We often saw multiple different application development teams within a single enterprise building applications that access the same underlying data. Zero trust, from a security perspective, was a big driver for these application development teams. Both the principle of least privilege, easy for me to say, both the principle of least privilege, which mandates that users should only get access to the data that they need and not to anything else. And also the need for continual reauthorization, i.e. each time a user attempts to take an action within the application, the permissions of those users or that user are reevaluated to reaffirm that they are indeed allowed to take that action. Some of the challenges that we saw within this class of applications was something we might label role explosion, whereby the number of roles within the organization grew substantially, to a point in some cases even where the number of roles exceeded the number of users. This inevitably becomes a challenge to manage permissions, and we'll talk a little bit more in this session about how verified permissions can help you meet that challenge. The second class of applications were customer-facing applications. These are applications built by organizations to sell, deliver, and support that organization's products and services. The organization in question might be a retail organization, might be a financial services organization. The characteristics of permissions management in this class of applications are that the access is based on the relationship that the user has with the organization. Customers aren't organized into neat hierarchies in the way that employees often are, and rather it's the nature of that customer relationship that drives the permissions that that user has within the organization. UX, as you imagine, is everything in a customer-facing application. The application is your front window or shop window out to the world. And so the user experience that you deliver is critical. And any frustration that customers might experience can negatively impact how they use your services and the extent to which they do indeed use your services. Some of the challenges we see here from a permissions management system is that users want to manage their permissions themselves, as opposed to centralized administrators managing permissions for them. A user of an online banking application might want to be enabled to delegate access to a trusted signatory, for example, on the account. And the third class of applications that we saw was software vendor SaaS. This is where the software is itself the product. In other words, our customer is building a piece of software that they then sell to their customers. These are typically workforce-oriented applications like CRM systems, HR systems, ERP systems, and the like. One of the characteristics that play a significant part when we think about permissions management is that these applications tend to be multi-tenant. And each tenant may have its own identity provider, and therefore a slightly different way of representing the identities and the attributes of the users at that tenant. And that, as you might imagine, does become a factor when we think about attribute-based access control models. One of the challenges from a permissions management perspective is the need to support custom roles, because each tenant will have a different view on exactly what a role in that organization is permitted to do. So those were the three different classes of application that we saw. We also saw IoT and some other types of application as well. I want to talk now about the personas. Who's actually using this product? Who are the stakeholders for it? There were three key stakeholders that emerged: the application developer, who is building the application; the access administrator, who's then responsible for managing permissions within the application once it's built; and the compliance manager, who cares deeply about how the permissions are set up, because that can impact the extent to which their organization is in compliance with either their own internal mandates and guidelines or externally driven guidelines and mandates. I want to deep dive onto the application developer and what does this product mean to them. You, as an application developer, care about three things. I mean, you care about multiple things, clearly, but these are the three that bubble to the top in the conversations that we've had with customers in the context of verified permissions. Firstly, you care about being able to build faster. You're working to tight delivery timelines, and any product that provides out-of-the-box capabilities that you would otherwise have to build yourself is of significant interest to you. Secondly, you care about the features within your application. You're proud of what you build, and you want it to be a strong product with interesting and exciting features. And thirdly, you care about building a secure application and passing that AppSec review. Now, in the context of the first, we identified, or rather, one of our customers identified opportunities to accelerate application development by up to 20% by being able to externalize authorization. In other words, close to 1/5 of the functionality that they'd built within their application pertained to managing who was allowed to do what within that application. So how does an application developer engage with the product? There are three steps or three levels. The first is to define your authorization model. This can be represented simply as a narrative that describes who is allowed to do what within the application, and would be written in conjunction with the business owner of the application or the product manager. So in this session, we're going to focus in on an imaginary pet store application. And therefore, as we start to write the narrative that describes the authorization model of that pet store, we're going to think along the lines of, well, anyone can register on this pet store, thereby becoming a customer. Customers are allowed to add pets for sale, search pets. So you can see there what we're beginning to do is to describe both the different types of entities for which we'll be defining permissions, in this example, a customer, the actions that those principals are permitted to do, searching for pets, posting pets for sale, and the resources themselves on which those actions are being taken, in this instance, pets. The next step in the process then is to formalize that narrative in the form of a schema. The schema describes in a declarative syntax, the entities that you are creating permissions for, the actions that can be taken on those entities, and the resources that those actions are being taken upon. In this example, the namespace is pet store. The action called out here is search pets, and it applies to the resource type of pets. So you've defined in a narrative form the permissions model. You've created a schema that describes that in a formal syntax. The next step in the application developer's journey is to define what we call the application level policies. These are the policies that apply broadly across the application. For example, the policy we're showing here permits a principal in the user group customers to take the action search pets on any type of pets. So there you see we've now defined our policy. And that policy will broadly apply across the whole application. And when we get into the demo later, you'll see how an example of actually us going into the application and creating the policy. You can also create as an application developer templates. These are shells of policies that then get filled out when the end user uses the application, enabling policies to be created on the fly or at runtime during the use of the application, and not just necessarily all policies being defined up front. What was the third thing that we learned through our gated preview? It was the importance of fitting in. The identity ecosystem is rich and established, comprising identity providers, identity governance and administration, orchestration providers, privileged access management software, API gateways. As an authorization service, we need to fit within that identity ecosystem and be able to explain to our customers how verified permissions works with the other extremely compelling products in that space. And so we're very excited to announce our launch partners, CyberArk, Ping Identity, Strata, and Transmit Security. These are partners with whom we've documented how to co-deploy verified permissions with these solutions in order to enable joint customers to benefit from the synergies between our product and our partners' products. Which brings me to the fourth thing that we learned, which will come as no surprise to anyone, no one wants to read the manual. What application developers want is a working example that they can get hands-on experience with and start to explore how the product works and what it can do with them. So no instructions on making pot noodles. Let's give you the pot noodle out of the box, as it were. And so to provide you and show you how to use the sample application that we are providing with verified permissions, I'd like to transition to my colleague Abhi, who will start the demonstration for you.
Thanks, Julian. So I'll quickly go over a demo which uses Amplify, Amazon Verified Permissions, and Cognito, a small sample application that uses these three services. The demo is for a pet store that allows customers to search for pets and order them. And then it also has a persona for store owners who actually can list all orders for their pet store. So this will cover the basics of authorization, how you can create Cedar policies, and how your application interacts with it. So to begin with, while Julian was talking, I deployed a fresh instance of the application. And so it doesn't have any users yet. So to begin, I'm going to start by creating a couple of customers. So the first customer I create is Abhi, my name. And then I'm going to create another user called Mark. Awesome. And to recognize in my app that both of these users are customers, I'm going to add them to a group called customer. Okay, created the group and then added Mark and Abhi to this group. Awesome. So now I have authentication for my app setup. Essentially, Abhi and Mark can log into the app. But this didn't cover the permission management and authorization piece. For that, I'm going to use Amazon verified permissions. So I navigate to the console and I get started by creating my first policy store. A policy store is a logical container where your CDAR policies reside in. When a user takes an action in your application calls verified permissions with a specific policy store and check whether access is granted or not. Let's try to create our first policy store. So I hit get started and I hit create a new policy store. And we provide three methods for creating your policy store. You can either use a guided setup, which is a wizard-based setup. We have three sample policy stores for you to get started and learn more about the service. For the purpose of this demo, I'm going to create an empty policy store. Great. So that was step one. The second step is linking my application to Amazon verified permissions and this policy store. So I'm going to copy the policy store, and then I'm going to go into my application, which is a Lambda function, and then set it up as an environment variable. Save. Great. So remember, we created an empty policy store, which means it doesn't have any policies. By default, we do the safest thing, which is we deny any action, or deny every action when we have no policies. But that's not very useful for my application. So let me go ahead and create a first policy that allows customers to search for pets and place orders. I have this policy pre-created, so I'm going to skip the wizard and I'm going to paste in my first policy. Great. So what does this policy say? Let's dissect this a bit. So the first thing it says is this is a permit statement. So permit any principal, the user, who is in this group called customer, to search for pets and place orders. Great. And let me just quickly save this and first give it a name. So customers can order pets and search for pets. I create a policy. Now that I've created this policy, let me go to my app and see if it works. So I log in as Abhi. Okay, and I'm going to say search for pets. Okay, so it returned a decision called allow. And the reason it returned this decision is because of this policy ID ending in WKH, which is the policy I just created a couple of minutes back. Okay, so that kind of works out. So that's one authorization, which is a very broad authorization. It applies to everyone in customers. Now, at times, you need to scope down what permissions customers have. In this case, and in my pet store application, I want customers to be able to view their own orders. And remember, customers can only view their own orders. I cannot view someone else's order. For example, Abhi should not be able to view Mark's order, and Mark should not be able to view Abhi's order. So let's write an authorization policy that helps with that. So I go back to verified permissions, and I'm going to create another policy. And just as before, I have a policy created beforehand, which I'm going to just copy paste in here. Okay, so let's just run through this policy. So this policy basically says, permit any user who's a customer to take an action called get order. But now I've introduced this when clause. So this when clause allows you to specify attribute-based conditions. In this case, I've said the principal should be same as the resource owner, only then access is permitted. So let's just give this a name. and say policy. Okay, now I go back to my app and I hit view order. And so, yes, this action is allowed. And the reason for that is the way I've coded the app is it always tries to get order one. And I've also hard coded such that order one is owned by Abhi. And so, because I'm logged in as Abhi, I can see order one. Now, we also want to make sure Mark cannot see order one because Mark did not place order one. So, I sign out, I sign in as Mark. Great. And I say view order. And so Mark is denied to get order one. And the reason for that is Mark does not own order one. Okay, so this makes sense. There are a set of customers who can do certain actions in the app. The other thing I want to quickly demonstrate is this concept of roles. Roles are a very intuitive way to think about permissions that we see very often used in a workplace environment. In a very simplistic world, roles map to your job function. So I wanted to build a quick demo where I have a role called store owner role, which is allowed to view all orders of in a store. Okay. So to do that, the first step is creating a store owner and adding them to the role. And so I create a new user called Kate. Create. And then I create a new group called store owner role. And then I add Kate to this group. Okay, so this solves the authentication side of it. Now let's solve the permission management side. And for that, I'm going to create a policy. As before, I have a policy pre-created, so I'm going to skip this step. Okay, and so let's run through this policy. So this policy says permit any principal who's in the store owner group. This is the group I just created in Cognito, and they can get store inventory and list orders. So I create this policy. I go back to my React app, log in as Kate, and let's see if she can view all orders. Okay, and so I hit list all orders. And it does, in fact, result in an allowed decision because of this policy ending QF3, which is the policy I just created for store owners. Okay, this seems to work well. Verified permissions and we together solved role-based access controls. Well, actually, not really. While this is a good way to go about it, we still see a lot of customers falling into this problem called role explosion. So what is role explosion? Role explosion is when you have hundreds and thousands of roles and managing and auditing roles becomes really challenging for your organization. Okay, so I tried to understand why that was happening. And one of the biggest reasons was we started defining roles to give access to a small set of resources. We started with this concept called least privilege, where we should give a small number of people access to a small set of resources. And then we defined a small set of resources and created a role for it. Let me try to demonstrate it in my sample application. So Kate did really well. She had a pet store in Austin, which was very successful. And she realized that she was very good at writing software. And so now she also sells this software to other pet store owners. And so Julian runs a pet store in London, and he bought this software, and then uh, other individuals similar to Julian bought this software all over the world. And now she needed to add a rule which says you can only list orders for the store you own. You can't list an order for an arbitrary store. And the most intuitive way she tried to solve this was create a role for every store that she sold the software to. So she had a role called Pet Store Austin for her own store, Pet Store London, which is Julian's store, and then for each store she had a role. But very quickly realized this doesn't scale well. So how do we solve this problem of role explosion? Well, one way to solve it is by combining role based and attribute based permissions. Let's try to do that. So we go into verified permissions and we go ahead and update this policy for store owners. And we do that by adding a when clause. Okay, so what does this when clause say? So this when clause basically says, as long as the principal's employment store code, basically where the principal works or the store they own, is the same as the resources store ID, then provide access. So we save this policy and quickly realize we need some place that captures uh, which store does the principal work in. And to do that, I go back to Cognito and configure it as an attribute for store owners. So in this case, I'm going to go into Kate. I'm going to add an attribute called employment store code. Oh, I am geeky. I was a developer before being a product manager, and so I come up with all sort of names. And so great, she owns the Austin store. I'll save this. And then I'm going to go back to my React app. Now remember, attributes in Cognito are passed on to verified permissions through the identity token, through the JOT token. And so I need to just refresh my JOT token so that it captures the attribute. So I log out and log back in as Kate. And this is where I say which pet store she's asking the order for. And so if I go to Austin, that action is allowed because she owns Pet Store Austin. Now we also want to ensure that she cannot see orders for Julian's store, which is in London. So let's change this to Pet Store London. So this should result in a deny. And it did because she doesn't own a pet store in London. So this kind of was a quick demonstration of how you can solve the challenge of role explosion using Amazon verified permissions and combining role-based and attribute-based policies. So we created one policy that worked across all the stores. Okay, great. So this seems to solve a lot of stuff. But how do I get from my current code, where permissions are hard coded in my applications code, to a place where permissions are externalized to Amazon verified permissions? Well, we have one strategy for you, which is a 3-step plan. And let me quickly switch over to my deck to show that plan. So how do you get started? And how do you externalize permissions? We have a 3-step plan. The first step is to add a piece of code that calls Amazon verified permissions, and this is authorized block. You do nothing, you discard the results. But what this provides you is a CloudTrail log of who is accessing what. So you have a complete picture of who is trying to access what. Well, in the next step, you set up your policies in Amazon verified permissions and you start shadow testing. What do I mean by that? So you get a result from Amazon verified permissions, which is the shadow result. You get a result from your code or from inside your application. And then you compare the results and see how many times it fails and how many times it succeeds. Okay, great. Third, you keep adding policies and making adjustments so that the two match. And when you see that they match all the time, you're ready to take step 3, which is to enforce these permissions using Amazon verified permissions. And so you write this code where if it's not authorized just return access denied. And this enables you to remove all your authorization logic from your code and move it to Amazon verified permissions. A simple three-step process. First, call verified permissions, discard the result, then start shadow testing and comparing the results. And lastly, remove code from your own application and then enforce the result you get from verified permissions. Okay, so if I had to leave you with one message today, it would be don't build your own permissions management system. It's hard. Instead, take advantage of Amazon Verified Permissions, which is a hosted AWS service. Again, I want to thank everyone for taking the time today and learning more about Amazon Verified Permissions. Thank you.